Hello there, Jamie. Okay, hello, Jamie and Alana. So for these office hours, I'm not usually going to prepare anything. I'm going to just basically be here to answer any questions and go through things in more detail. Hey, Laura.
Hello, morning.
Good morning. Any questions I can answer?
Well, I was interested in more info. I liked how you explained everything relating to water, but I guess now what's the next step? If we understand how the circuits relate to water, how do we kind of understand that independently of that analogy?
What do you mean independently of that analogy?
So if we were to take out the whole idea of water, how do we just focus on the circuits?
All right, let me.
Without always having to think about how we relate it to water. Do you see what I mean?
Yeah, so trying to let me have a, I don't want to use this one. Let me just pull up another one. So let me do. So for our circuits, so like we're going to start looking at, so let's just say simple circuit is a battery. Battery is going to have a positive and a negative. And then I've got some wires with maybe a switch and then a light bulb. Once I close the switch, now I'm going to have a force which is going to move electrons in the circuit, and they're going to go from the negative terminal to the positive terminal, almost like water flowing. And thinking about this in terms of water, so our battery is in a sense like a pump, except it's not pumping water in this case, it's supplying a force to move electrons in a circuit. The wires themselves are almost like the water pipes. So this is what the water is flowing through. And in this case, the pipes are the wires, which are holding electrons. And then the battery is like the pump, which is moving electrons. Don't really have a good analogy for a light bulb. But it's really hard for people to visualize, what's going on, these teeny tiny little invisible things called electrons, which are moving in a circuit. And so it kind of just used the water analogy just to let people have something they can think of. So after I use this analogy, just to get people thinking about, okay, instead of water flowing through a pipe, it's just electrons flowing through a wire. Then we're just really going to start to focus on the circuit itself. So I'm kind of just using the water analogy to get people thinking about, okay, a circuit I can imagine is almost like water flowing through a pipe. It's not exactly the same. I don't know if that helps at all, but yeah, I'm not going to continue to use this analogy the entire time. It's just a useful thing for people to think about because it's so hard to imagine electrons flowing in a wire.
Okay, that does help.
Clicker questions, no, PowerPoint. Yeah, so there's other analogy, like another analogy we'll use also is, and again, there's lots of different analogies that people use, partly just because it's challenging to think about what's really happening inside a wire. Another analogy they sometimes use is, in essence, a battery is like it's increasing the energy of the electrons so they can go from sort of a higher energy state to a lower energy state, or higher pressure to lower pressure, or higher elevation to lower elevation. So another analogy they use, oh, and you can't see this, when I have this on PowerPoint, this is moving, but a battery, you can almost imagine it's like a little elevator, and it's taking charges from a lower elevation to a higher elevation. And then when they go through something like a light bulb, it's using up that energy. But this is not a great analogy because one, This is showing positive charges which are moving. In reality, it's negative electrons that are moving. So we'll use some analogies, but I'll be very specific about exactly what you need to know for this chapter. Big things are batteries are supplying the force to move electrons already in the wires of whatever you're connecting to the battery. So like here, the battery is not supplying electrons. So that's a little bit different. So when you pay for your water bill, you're actually paying for water, right? You're actually getting water pumped through your pipes. But when you connect something to an outlet, PG&E is not supplying electrons. The electrons are already in the wires of whatever you're connecting to the battery. If it's a conducting wire, which it has to be if you're going to have a circuit, then it has a bunch of electrons that aren't anchored to any particular atoms. Those electrons are sort of free to wander. And when you connect something to a battery, that battery basically pushes the electrons from the negative terminal through the wire, through whatever you're connecting to the positive terminal. So the battery is there only to supply the potential difference or to give it the force to move electrons in a circuit. So a quick question, do you guys know what is the voltage of most batteries, at AA, AAA, C, and D batteries?
Yeah.
So most batteries that you buy are 1.5 volt batteries. The actual number is not that important, but kind of interesting. The only difference between like a AA battery, a AAA battery, a C battery, a D battery, these are all 1.5 volt batteries, meaning they all supply the same amount of voltage or potential difference. The only difference between a AA, a AAA, a C, and a D battery is how much energy they're storing. So a D battery is still providing 1.5 volts as a AAA. It's just the D battery is going to last much, much, much longer. Just a little side point.
So what's actually in a battery that's doing all of this work?
You have what's called an anode and a cathode. So I'm not going to go into it, but basically you have, in a sense, two pieces of metal. Because of the chemistry of it, you have electrons that want to flow in the opposite direction they want to flow electrically. So it's a little bit challenging to explain, but because of chemical properties between the anode and the cathode, you basically have electrons wanting to be moved from one to the other. And I always forget whether it's the cathode or anode. But basically you have, I don't know if you ever did this, but you can make a circuit just using like a lemon and then a couple pieces of wire that you put into the lemon. You just have to have, I'm not explaining it well. You don't need to worry about what's happening inside the battery, but you have these two, basically, in a sense, pieces of metal. One of them wants to give up electrons, the other one wants to gain electrons, and you have electrons moving from one to the other inside the battery. That's what's basically keeping one end more positive, the other end more negative. And again, not going into all the mathematics of it, it's challenging to think about, but inside the battery, because of the chemistry of what the battery is made of, electrons are constantly being forced, in essence, from the positive terminal to the negative terminal.
So what happens when a battery runs out and goes dead? What has gone on that made it
In
die?
essence, the two plates have equalized, meaning one plate wants to gain a bunch of electrons, the other one wants to lose a bunch of electrons. Once enough electrons have been transferred from one to the other, it's almost like the water levels becoming the same. There's no more difference in pressure, so there's no more charge or water flowing. So what what's happening in a sense is, if you want to use this pressure analogy, inside the battery, you basically have water being pumped from the lower level to the upper level. But as a battery gets used, those levels change. And so eventually, in essence, what happens is the water level from each side balances out. So the cathode and the anode are no longer wanting to lose or gain electrons, and they basically are both at the same level in a sense.
So that's why a 9-volt battery lasts longer. Really, it's bigger. It has more of that material to just go
And yes,
longer time until
exactly.
equalize.
So yeah, I've never done this before, but you know, if you had, I don't know if you remember these old boom boxes, but I had an big old boom box as a kid, and it took something like 6 or 8 or 9 D batteries. You could run those off of AAA batteries because they're still providing 1.5 volts. It's just, it wouldn't last very long at all. A D battery just, in a sense, stores a lot more energy than a AAA battery, but they're still providing the same potential difference. So AA, AAA, C, and D batteries, those are 1.5 volt batteries. A 9 volt battery is a 9 volt battery.
Oh, I see. Okay, so what about a rechargeable battery versus not? Like, what makes a rechargeable battery something that can regain that ability versus a battery that just dies?
That's a good question. And the best answer for that is I don't know. What I can tell you is that the rechargeable battery is made out of slightly different material, and you can, trying to think about the best way to explain this. As these inside a battery, you know, as the water level in a sense starts to equalize, what a rechargeable battery does is you're plugging it into an outlet, which in a sense then forces the difference in pressure to be about 1.5 volts again. And then as the battery runs, the pressure difference becomes less and less and less, and then you recharge it again. So in essence, what is happening is, again, I forget if it's anode or cathode, but once those two have about the same potential difference, then what a rechargeable battery does is you plug it into an outlet, and because of, I don't know what's actually happening, but you're forcing electrons to get moved from one to the other, so you're maintaining that potential difference.
Okay.
So let me stop this one, stop that share. All right, other questions I can answer on chapter 23 or anything about this new paradigm of moving online?
I have two, well, one kind of like question and one
Okay.
like comment.
Okay.
The question is, are you going to go over the quiz answers? I was able when I logged back on to Mastering Physics to find out my quiz grade, but it still doesn't show me like which ones I missed.
Ah, that's a great question. I think I hadn't thought about that. Yes, I will. What I'll probably do at some point a week or two from now is spend just one lecture period, or maybe I'll just make a video on my own, where I will go through all of the quiz questions and answer them. And it may be, I'm also planning on doing like one lecture every couple of weeks where we just look at, let's say, clicker questions and things like that. So that might be a good time during that to also look at all of the quiz questions.
Yeah. I was also, my comment was more about, like, I know other people taking online classes too, and they have the ability, or their professor, I guess, has the ability to put them into like chat groups. I don't know how to do it, but I know that they have been doing it that way. And like, I thought that might be helpful with like doing clicker questions so we can still kind of talk with like a group of people. I thought that might be helpful.
Oh, yeah. So there is something called breakout rooms. So I can assign people to breakout rooms. I'll think about that. I haven't played around with that feature, but yeah, it would be nice to maybe have some discussion questions where I break people up. So what I might do is maybe every couple weeks, I'll do a lecture that's more focused on looking at clicker questions, looking at the results of the quizzes that you guys took, and then maybe doing some conceptual questions where I give you the question, let people break off into breakout rooms for 30 seconds and then come back and discuss it.
Yeah, because I feel like those kind of questions help me learn the material better.
Okay, yeah, I like those ideas. And I'm always open to, you know, tweaking how I'm doing things. So if another instructor is doing something that's really useful, please pass that along to me so I can do it also if it seems like it's going to be useful for Physics 10.
There's a question in the chat.
I have a question about the assignment. Should I submit it through Mastering Physics? So yes, so all homework and all quizzes now are going to be done through Mastering Physics, probably the celebrations too. I'm not quite sure how celebrations will work in terms of short answer questions. I don't know, I'm still working it out. It may be that the celebration is just all multiple choice, but I don't like that, so I'll probably still do a couple short answer questions where you're just gonna end up having to type in the answer. But short answer is yes, all of the homework will now be submitted through Mastering Physics. And just so you know, in terms of submitting the homework online, it may give you a grade. I haven't quite looked at that yet, but it's still just going to be graded on completeness. So if you get an answer wrong, you're not going to lose points on homework. I basically just want to make sure that people are continuing to stay up with the course. And then another thing is when I sort of do a lecture on clicker questions, I'll probably go through and answer all of the homework questions also. Or maybe I'll do one class a week where I'm just doing homework questions, but I'll find a way of answering all the homework questions, answering all the quiz questions, and things like that. So thanks, Angelique.
Chapter 22 is due today.
Chapter 22, no, it's due on Thursday. So 2 things on Thursday. There's the Mastering Physics, just to make sure people can use the software, and Chapter 22. And then I think I have the first quiz is Friday.
Okay,
But keep in mind, one quick thing, those are just the absolute last dates for them. Most people hopefully are done Chapter 22. You can submit it at any time. And same thing with the Chapter 22 quiz. You can take that at any time before Friday at midnight.
Okay, I thought I saw something that was due 3/31, which is today.
Oh, so that was just a reading assignment.
Okay.
So the reading assignments are not graded. So let me just share the screen with you if I can go to, hold on a second. Let me pull up one of these. Course home. Okay, time's up. You cannot submit any more answers for this assignment. All right, let me go back to my course home. Oops. All right, so I'm gonna share course home, share. Okay, so this is the Mastering Physics for Conceptual Physics. So completed assignments. So yeah, there was a reading assignment due today. So just to show you, these reading assignments are not graded. They're there just to make sure that you're completing the work and you're staying on top of everything. So it's up to you whether or not you want to, you know, read through it all. I'm not going to mark people off, but taking an online course is much different than taking an online or a live course. And so it's really important that people stay on top of everything. So these reading assignments are just there to make sure you're staying on top of the material. If you wanted to like read a specific section, you know, if I click on Coulomb's law, it'll then take me to that particular section of the book. If I wanted to read it, eventually opening up Chapter 22. So you can just click on any one section, or like for me, I was just showing people this earlier today, you could just click, hey, I read this in my book, mark it as completed. So the things that are sort of due that are going to be graded is by Thursday, this Mastering Physics and Chapter 22 homework, and then the first quiz is going to be Friday. And again, that's just the last day that you can do it. Let me stop that share.
Are you moving the class?
Hey, Adam. Hey, just so you know, I'm still in Physics 10 office hours.
Okay, all right.
Yeah, so I'm not going to start lecture for 4A until 11:15.
Okay,
Sound good?
sounds good.
All right. Hey, Jeff, were you able to create an account on Mastering Physics? Oh, I see you're unmuted. I can't hear anything. I have a question.
Oh, are you talking to me?
Yeah.
Oh, sorry, my internet was down, so I couldn't hear you.
Oh, no worries. I'm wondering, you were emailing me about not being able to access Mastering Physics?
Yeah, I was just trying it again.
Okay, let me know. Send me an email this afternoon. Everything is up and running now.
Yeah, it is.
And then if you can't access it, send me an email and I'll see what I can do tonight.
couldn't access it.
What's that?
I couldn't access it.
You couldn't access it?
Well, I mean, I signed in, but nothing. I couldn't like upgrade it, or I couldn't see any of the assignments or upload anything.
Okay, and I don't remember, did you email me?
I did.
Okay, so I'll look at that. I forget, did you email me your username and password?
Yes.
Okay, so I will look at that when I get a chance. Tuesdays and Thursdays are a little tough. I get my daughter at 12:30, so I don't have much time after I do all these lectures and stuff, but I'll look into it and see what I can find out.
Totally understandable.
Any other questions before I end this office hours? And just so you know, I'm going to upload this to YouTube. Same thing with the lecture that I just gave before this. So you can always go back and rewatch things if you need to.
I have another question kind of about those pictures you were showing us near the end. What did you say the resistor does for the circuit?
Okay, let me go back to sharing the screen. Share. Okay, so a resistor is basically this really small little device that is designed to have a specific resistance. And the reason you use them is if you want to limit how much current is flowing through a particular part of a circuit, then you can put a resistor there. So for example, if I have let me annotate, draw. So if I have a simple circuit, I got a little battery. Here's my positive, here's my negative. So I'm going to have a certain amount of current flowing. And if I want to know how much current, it's basically equal to the voltage divided by the resistance. So the resistance is the resistance of the entire circuit. So batteries have a certain amount of resistance. Light bulbs have a certain amount of resistance. Wires themselves have a little bit of resistance, but not very much. Let's just say that for some reason there was too much current flowing and I wanted to decrease it. Well, what I could do is, rather than just have wires, I could have a certain resistor that's going to have a certain resistance here. We usually label it with an R. The bigger the resistance, the less current is going to flow. So what I was talking about here is a resistor is kind of like a section of pipe that's hard for water to flow through. So in this case, they're just indicating it with a jagged line and just indicating that, you know, it's pretty easy for water to flow through a pipe here, but it's going to be much harder to flow through something where the line is all jagged. Similar thing with a resistor. It's just a little device that makes it harder for current to flow through it. And so I can use resistors to limit how much current flows in a circuit. If I want a lot of current, then I don't want very much resistance. If I want a little current, then I want a much bigger resistance. And so if I wanted to decrease how much current was flowing here, I could add a resistor into the circuit.
Can you give an example of a resistor that would be used?
Let me see if I can. Let's do a Google search for resistors. Images. Okay, can everybody see this?
Yeah.
You guys, okay, so these are basically what resistors look like. They're just these little devices that you can insert into a circuit, and the resistors have a specific resistance. So we're not doing that in this class, but in a more mathematical class, each one of these lines means something. So you can tell how much resistance a specific resistor has by looking at the color coding. And so, yeah, we'll go into this a little bit more, but these are basically just these teeny tiny little devices that you put inside. So like here's one, if you ever look at a motherboard, or if you ever look at inside of your computer, you have really, really complicated circuits. You know, what we're doing now is a very simple circuit, just a battery, some wires, and a light bulb. But if you ever look inside a computer, it's way more complicated. But these are just all these different resistors being soldered together in this circuit. And so if I want a specific part of the circuit to have less current, I would use a bigger resistor. If I wanted a certain part of a circuit to have a lot of current, I'd use a small resistance.
What would make you, or how would you know that the current is too high, or like why would it be too high that you would want a resistor?
Not being an electrical engineer, I could just give you a general thing, but you know, like in a computer, let's say you've got a certain amount of, basically it's going to depend upon the actual circuit itself. So something like, you know, like a hairdryer is really just something where the wires get really, really, really hot and you're just blowing air past it. So what happens there is you have a huge amount of resistance, because as electrons are trying to travel through a wire, when there's a lot of resistance, the wire ends up heating up. And so let's say I have a hairdryer and I want a lot of current flowing through a particular part so that it gets hot, then I'd have a very low resistance in that part of the circuit. So certain devices are meant to have more current, some are meant to have less current. So in, you know, a complicated thing like a computer, maybe the hard drive is supposed to get a little bit more current or less current than the memory, than the processor, things like that. Okay. So you're connecting everything to just a 120 volt outlet, but you want different amounts of current flowing into different parts of the circuit, and you can control that current by using a resistor. If you want more current, you have less resistance. If you want more, if you want less, I've been talking too long. The more current you want to have a lower resistance. The higher the current, I said that again. Lower current, you want more resistance. More current, you want less resistance. So you can control how much current there is in different parts of a circuit by controlling the resistance of that particular part.
And then the switch on that circuit just turns it on and off.
Say that again?
And then the switch on that circuit just turns it on or off?
Yeah, so anytime you are turning on a light switch, all you're doing is either opening up a circuit or closing a circuit. When I want to turn on the light switch, I'm closing the circuit so I have a complete circuit. When I want to turn it off, in essence, I'm opening up the circuit.
Okay, thank you.
All right, so I'm going to stop office hours now. I have another lecture in Physics 4A coming up. I'm going to post today's lecture and today's office hour to YouTube, and then I'll send out an email to everyone when they're all set up.
Can you hear me?
Yes, I can.
I just have a quick question about the PowerPoint slides.
Okay.
So for Thursday's lecture, what tab are the slides going to be under? Because under electric current, I only see 3 slides, which are the ones you showed today.
Hold on one second. Under what tab are you talking about?
Your PowerPoint slides on your homepage.
Uh-huh.
I only
let me just say, Joe, so let me share the screen so we can all see it. Share screen. Share.
So under electric current, or are you going on to magnetism next on Thursday?
No, so I'll still be doing electric current. So let's see, when I open this up.
Oh, I don't know why. I'm only seeing 3 on mine. Maybe it's because I'm on my iPad.
So one other thing I should let people know this. When you click on a PDF on your phone or on an iPad, sometimes it just opens up the very first page. What you want to do is press your finger on the link, and it should give you something that says open in a new tab. If you then open it in a new tab, then it should be the entire PDF file.
Okay, I see it now. Thank you.
All righty. All right, I'm going to stop it, and I will have, again, on Thursday, we're going to do a lecture again from 9:30 to 10:15, and then office hours, 10:15, 10:20 until about 10:45, 10:50. So everybody stay safe. I will see you on Thursday. If you have any questions, shoot me an email. And yeah, don't forget Thursday homework due, and then Friday's first quiz. Good luck. See you guys on Thursday.